Welcome to a journey through specifying fires, a DRU CPD course designed for architects and specifiers. We're going to take an informative journey through the world of gas and wood burning fires. We'll cover the different kinds of fires available, comparing relative efficiencies, installation options, venting challenges, and how to overcome them. The objective of this session is to increase your knowledge and understanding of the choices available. This will enable you to confidently specify the most appropriate fires for new build and refurbishment projects. Some brief company history. DRU is an acronym for Dippenbroek and Reigers of Ulft in the Netherlands. The company was founded in 1754 and began by producing cast iron pots and pans. Fireplace production came later, and following the discovery of natural gas in Slotterven in 1959, DRU has specialised in the development and production of domestic and commercial gas-fired heating appliances. To mark its 250th anniversary in 2004, DRU was awarded the title of Purveyors to the Royal Dutch Court, cementing its excellent reputation. As well as our HQ in Duiven, we have subsidiaries in the UK and Belgium, and distributors in 26 other countries. Since 2009, DRU has also undertaken the production and distribution of wood-burning fires and stoves. Firstly through the acquisition of Dutch manufacturer Dick Geurts, and more recently by its merger with the German company Spartherm. Here are 4 examples of products from our gas and wood portfolios. We have a typical Spartherm built-in wood-burning fire, a Dick Geurts suspended circular wood stove, a global by DRU gas fire compatible with UK chimneys, and a DRU 3-sided designer gas fire, which can be installed without a chimney. The last model is a good example of a fire that uses the balanced flue system, which was originally developed by DRU and now forms the basis for many millions of gas heating appliances worldwide. We now move on to some of the innovations that DRU is best known for. This diagram represents the exclusive DRU Power Vent Extended and Fan-Assisted Flue System. This enables the installation of multiple gas fires in large properties, high-rise apartments, hotels or office developments. More on this later. EcoWave is a piece of gas fire technology controlled by an app for smartphones and tablets. It enables the creation of a bespoke flame picture while saving up to 30% on gas usage. Next, the balanced flue system makes it possible to construct fireplaces such as this tunnel model, which can be installed in room-dividing walls and other architectural features. Finally, when you construct a false chimney breast, you can install DRU Lux elements to provide ventilation and an additional source of light. Now for the main agenda. In this course, we are covering 4 main types of fires. Open fires, with open combustion in gas and wood. These fires use conventional flues that are connected to existing chimneys. And closed combustion fires in gas and wood, of which the gas fires utilise the balanced flue system and the wood fires use external air connection. We will consider these different product types from 4 perspectives: efficiency, installation, fluing, and the various pieces of legislation which relate directly to fires and fireplaces in the UK. Here are 2 examples of open fires, one solid fuel and the other gas. They are installed into standard Class 1 chimneys, are open-fronted, and extract air from within the living room for combustion. So, we begin with comparisons about energy efficiency in open wood fires. Efficiency from 10 to 20% means that 80 to 90% of heat generated by these methods is lost up the chimney. This is because fire is an insatiable consumer of air. In an open fire, there is very little control over the air supply to the fire and its burn rate. And even if the fire is not burning, the chimney will still extract heat from the room and reduce the efficiency of the central heating system. UK building regulations specify a Class 1 chimney requirement. There are also requirements for constructional hearths and barriers, which extend 150 mm on each side of the fire and 300 mm from the front of the fire. In addition, because open fires deplete the air in the room, there's a requirement to provide additional free air to the room, further comprising the overall efficiency. These requirements are covered in depth in UK building regulations, specifically Section J. In UK smoke-controlled areas, all wood-burning appliances must have DEFRA approval. And in the whole of the UK, new wood fire or stove installations must be signed off by a HETAS registered engineer or by Buildings Control. Now we discuss open combustion using gas. Here we can see two typical examples of glass-fronted open combustion gas fires that are suitable for UK chimney installation. Modern open combustion or conventional flue gas fires have overcome the efficiency problems inherent in open fires by putting the fire behind glass. The main reason for this is that you have much more control over the air intake for the fire and therefore the burn rate, resulting in dramatically increased efficiency over open fires from around 60% to 90%. Combustion air is still taken from the room, so additional ventilation to the room is required, where the gas input to the fire is above 7 kilowatts. The amount of ventilation increases in line with the gas input. These factors are covered in UK building regulations, as are the chimney and hearth requirements. Finally, all gas appliances in the UK must be installed by a gas-safe registered engineer and require EC approval. Next, we deal with open combustion when burning wood. Here we can see two examples of wood stoves, one contemporary and one traditional, and two types of built-in wood fires, one in a standard brick chimney and one in a false chimney. As with gas, open combustion with wood is achieved through putting the fire behind glass, with equivalent efficiency increases. Chimney and hearth requirements are specified in UK building regs. Additional ventilation to the room is required, because like open gas combustion, the fire is taking combustion air from the room. The amount of free air required is covered in UK building regulations and is determined by the heat output of the appliance in kilowatts. So, appliances with a heat output above 5 kilowatts will require additional ventilation. These appliances must be DEFRA approved for use in smoke-controlled areas, and installations must have EC approval. Next, we deal with closed combustion when burning gas. Here are three examples of closed combustion gas fires: a three-sided built-in model, a see-through tunnel model, and a freestanding gas stove. Closed combustion with gas utilises the balanced flue system. This requires the use of a concentric flue, or pipe within a pipe, where combustion air is drawn from outside through the outer pipe and exhaust gases are expelled through the inner pipe. Balanced flue appliances do not draw any air from within the room, so there's no requirement to provide additional ventilation. There is only a requirement for a decorative hearth, when the appliance is placed less than 450mm from the floor level. And of course, all gas appliances installed in the UK must have EC approval. Here is a picture of a typical balanced flue, which clearly shows the pipe within a pipe. The diagram shows the balanced flue assembly installed inside a cavity wall, a space-saving and efficient alternative to creating a false chimney breast. Flueing for balanced flue gas fires differs from our previous examples, as it's largely determined by the appliance manufacturer. This is often emphasised by the strapline "no chimney, no problem." Here we see examples of two balanced flue terminals on outside walls, one for a standard balanced flue appliance and the other for a cavity wall installation. This is the classic balanced flue system, where the concentric flue rises vertically from the fire for 1 metre, takes a 90-degree bend through the outside wall and ends up using a wall flue terminal. This is a relatively straightforward installation. Care should be taken on the positioning of the terminal, and it should conform to UK building regulations. For example, the terminal should not be positioned within 600mm of an opening window, or within 300mm of a permanently closed window. Developments in balanced flue technology have produced some appliances which can now be flued with a 90-degree bend directly from the top of the appliance, through the wall to the terminal. Please refer to individual manufacturer's instructions. Variations on using the wall terminal on longer flue runs, which may incorporate 90-degree and/or 45-degree bends, are permissible according to the manufacturer's instructions. Balance flue sizes will vary according to the appliance and the manufacturer, but a typical balance flue system has the outer pipe with a diameter of 150 mm and the inner pipe with a diameter of 100 mm. Here are other balance flue possibilities without a chimney. Again, the overall flue length, number of bends, and particularly the maximum horizontal flue length are determined in each individual manufacturer's installation instructions. This dimension can often pose challenges, depending on the positioning of the appliance. Flue gases will naturally travel vertically, so requiring them to navigate multiple bends and horizontal runs will affect the operation of the appliance. Manufacturers' fluing systems and materials, as specified in their installation instructions, must also have EC approval. Here we can see how a chimney can be utilised in a balanced flue installation. A flexible flue pipe is extended from where the initial concentric pipe penetrates a chimney closure plate. This flexible flue has a diameter corresponding to the initial exhaust pipe diameter, generally 100 mm, and runs the length of the chimney to just below chimney pot level. It's secured at both ends by a flexible flue connector and, at chimney level, is completed with a small vertical terminal. When exhaust gases are required to travel long distances and negotiate multiple bends or horizontal stretches than are permitted in normal balanced flue installations, special measures are needed. Some manufacturers have designed powered flue systems, which employ a fan to cope with more demanding routes. These systems fall into two main types: pull or push. Push systems will have a fan and power unit at the fire end of the flue run, with the fan pushing the exhaust gases to the terminal. Pull systems position the fan at the terminal end of the flue run, with the fan sucking the exhaust gases towards the terminal and out into the atmosphere. Typical extended flue systems can cope with flue runs of up to 100 metres in any direction and multiple bends. Pull systems have an advantage over push systems because any noise occurs at the terminal rather than the fire. All powered balanced flue systems installed in the UK must have EC approval. Here is a good example of an extended powered flue system installed in a luxury apartment development by Berkeley Homes in Belgravia, West London. The balanced flue gas fires in almost 90 apartments are connected to a series of terminals on the roof, ensuring realistic flames and efficient performance throughout the building. We now move on to closed combustion systems burning wood. Here you can see three examples of wood-burning appliances with closed combustion. We have a three-sided built-in wood fire, a three-sided freestanding wood stove, and a single-sided wide-screen built-in wood fire. These appliances, which would normally be expected to work with open combustion, can be converted to closed combustion by adding an external air connection. This means they extract air entirely from outside the building and are completely room-sealed. To summarise on closed combustion when burning wood, because all combustion air is drawn from outside, no additional ventilation points are required inside the room, and clean burning with high efficiency is guaranteed. As always, installations must be carried out by HETAS registered installers, must conform to UK building regulations, and manufacturers' instructions must always be followed. Now we can summarise the various categories covered in the course. Open fires, which are becoming increasingly rare due to energy and efficiency regulations, have the advantage of generating an atmospheric fire. However, they have very low efficiency, are constrained by having to be installed in an existing chimney, and require a lot of cleaning and maintenance. Modern gas-fronted fires with open combustion in both gas and wood certainly provide an effective flame picture and much higher energy efficiency than open fires. However, they're still constrained by having to be installed in a chimney and require additional ventilation points to be installed in a room. Modern glass-fronted gas fires with closed combustion have greater energy efficiency, require no additional ventilation, and offer greater flexibility of design and installation due to not requiring a chimney and the option of extended powered flue systems. The only limitations are those imposed by the manufacturer. Any questions? Thank you for participating in this course. Here's our contact details and the links for our website that cover all consumer and commercial products, as well as our technical support site for architects and installers. Please apply online for your CPD certificate.